Hi, I'm Tammy Neon. I used to be an accountant, then in 2023 I went on a course to learn how to fix cars. Welcome to my YouTube channel where I'll show you how to diagnose all sorts of faults. My channel does need you to like and subscribe, and these pesky adverts, well, as long as you watch 30 seconds of them, I do get paid something. I've started making my own show. It's like Wheeler Dealers, but it's got me in it, and more detail on the repair processes. You can find some of the scenes from it on this channel, or search Rusted or Busted. If you leave a message, I will reply to it. Thank you for your support. Let's get on with the show. So today's job has come to us courtesy of Volkswagen. Well, sort of, it came from a local garage down the road. But anyone that has one of the 2-litre TDI engines will have had, or at some point in the future will have, this problem. The fault code is P2015, intake runners, often referred to as swirl flaps. That's going to be in the first part of this video, and it's about 20 minutes long. There'll be points that you can skip to below, where I will also fix the windows, the ABS issue, and a fault that we have with the main beam headlights. Turn on the ignition and see what we've got. Okay. Right, so we've got a bulb out, we've got a fault with the electronic parking brake, engine management light, and then on the other side, ABS, traction control, and tyre pressure warning. They're all going to be related. The tyre pressure system on here, it works through the ABS. What it does is it calculates the wheel speed of all the tyres, and if it finds one tyre that's different from the other three, it decides that it must be deflated. The traction control also works through the ABS to stop the wheel from spinning, so as soon as you get an ABS fault, you get all three of these lights on. Let's get the diagnostics out and see what fault codes we've got. Here we go. Diagnostics. Find the car. Okay, Volkswagen. Accept. Okay, so diagnostic type, automatic selection, and read the VIN. Okay. It's feeling a bit slow today. Okay, this one's 3C, and this is a wagon estate. It's asking me for the engine code, which you can find on the VIN sticker in the door. This one's a CBAB. CBAB. Okay, yes, that's my car. Now it's establishing its communication. Diagnosis, auto scan. Here we go. Okay, report, let's see what we've got. Right. I'm looking for active static, here we go. Intake manifold runner position sensor, switch circuit. That's the engine fault, so that's why we've got the engine warning light on. Right front ABS wheel speed sensor, as we know. 2 for the headlamp bulb, right and left. What have we got? Got passive sporadic, function restriction caused by low voltage, and control unit in steering wheel, no comms. Oh, here we've got navigation system and radio. There is no radio, so I'm not surprised there's a fault. I've got passive sporadic comfort system, central control module. Motor for front window. Brake control module. Alarm horn. What else we got? Brake control module, and then the last ones are all just no radio, so they're okay. So So now I'm going to just erase all the faults and then turn the engine off, turn it on again, and that will clear any historical codes that we don't actually need to worry about. So here we go, escape, quick erase, pause, wait for it to do its thing. Okay, there we go. So take this out. That was faffy. Put it back in. Start it. Okay, turn it off. Put the ignition back on. Escape. Yes. And do it all again. So here we've got P2015, which is the intake manifold runner, and that's quite common on these diesel engines. So P0285, that's right front ABS wheel speed sensor, open circuit / short circuit. We'll do a quick test to see whether that's the sensor or whether it's a wiring fault. Left and right high beam headlamp bulbs. P01495 and P01499, that's the left and right high beam headlamp bulbs. I've got two codes here, navigation system and radio. We know they're missing, so we'll just ignore them. Got P01330, that is the comfort system. It says passive sporadic, but with all the faults that this car's got, we don't need to investigate it. This one's a B code, B11EC54, it's a body code. This one is motor for front window regulator, no basic setting. That one's quite an easy one to fix. We just need to press and hold and get the window all the way up, hold it for a couple of seconds, wind it all the way back down, keep holding it for a couple of seconds, and that will tell the car where the top and bottom of the window is, and it will clear the fault. Got P1316, that is brake control module. That kind of indicates that there could be some corrosion in the wiring plug to the ABS pump, which is why I said earlier we are going to have to test that. I've got an alarm horn one, which I'm not that worried about, and I've got the motor for front window regulator on the other side, so we can fix those quite easily. Yeah, and then the rest of them are just, there is no radio. Right, I'm going to start with the engine first, I think. Okay. This is a 2-litre TDI Volkswagen Passat, 2010. This is one of the last of the 2-litre TDI engines. It's the 16-valve common rail version, which they called the 2-litre CR. And our fault is with this bit. Now this part is a flap, and it basically converts the engine from an 8-valve to a 16-valve engine. And the reason it does that is because an 8-valve engine makes really good low-down torque, whereas a 16-valve engine makes good high-end BHP. Unfortunately, they get a build-up of carbon from the EGR system, and this causes the flap to become stuck, often breaking the gear or the arm that controls it. It may also be possible with the fault code we've got of open circuit that the motor is burnt out, or like on the Mercedes V6 turbo diesel, the wires inside have become brittle. So I have two tests. I need to check whether the motor will work on the bench, and I need to check whether the flap moves freely. There is an issue with this, that Volkswagen don't sell the motor by itself. It's a whole injection manifold, and they're about £1,500. Get some tools. I want to get better access, so I need to take off the air filter, which means taking off this pipe, and this electrical connector. Okay, start that. Next, I need to undo this special clip here, and there is a tool that we use for that, so I'll go get it. This is the tool I'll be using. Definitely made for men. I mean, look at that, I can barely reach. There we go. Put that on there. Let it get it. There we go. And squeeze. Woo! And off. This is how these clips work. Instead of being a sensible banjo clip, these things fly off and hurt your fingers. We're on our A of our ABCs, which is check the wiring. I'm going to check that there's power and earth and that none of the wires are really obviously broken. Now our fault code says range performance, not open circuit, so that does suggest the wires are okay. First thing I notice is that this clip is actually twisted. So it naturally wants to sit like that, but to get it in, it's all twisted backwards and squashed. Turn it on to continuity, check it's working. Yeah, good. Get an earth. Check that. And we're good to go. This test is with the ignition off, and I'm just looking at the earth side of the wiring. So I'm going to take some readings. I've got 3 wires that are fairly static, and I've got 2 wires that are fluctuating quite a lot. Now the 3 wires that are static are indicating that the wiring and the ECU are probably fine. Let's have a closer look at the other 2 wires. Just going to pull the wire around a bit. If you can hear that, I can make it go on and off just by moving it here, which is a good indication that there's something wrong with the wiring. Do the next one. It doesn't seem to change as I move it around, although it is fluctuating just generally. What we need to do is do a pull test on that wire and then have a really good close look at the other one. Pull test is where we pull back the sheath around the wires, And we use a screwdriver to lever the wires and pull them. If the copper wire is broken on the inside, the plastic will stretch and break. Oh, it's so sticky. I'm gonna get some appeal. I've exposed the wires. This is the cloth tape, and it's actually really quite difficult to cut through. It's passed its pull test, so the fluctuation that I heard is most likely the contact between the probe and the plug. I was holding it on and it is dirty. That's our initial test done, which we did with the ignition off. What it showed us was that the wiring in the ECU are probably okay. The 3 static readings that we had are the circuits going through the ECU components and to earth. The ones we had that were moving around could have indicated damaged wiring. However, the most likely to be damaged bit of wiring right at the end seems to be fine. Those readings that were fluctuating is probably that the circuit goes to a transistor inside the ECU and doesn't have what's called a pull-up or pull-down resistor on it. The fluctuations are a result of the ECU responding to the low current that the voltmeter was putting in. We're going to repeat the test with the ignition on, where we'll be looking for our earth circuit and our power circuit. Let's crack on. We have 12 volts, 12 volts, nothing, 5 volts, and 5 volts. I've got 12 volt, nothing, 5 volt, which means I've got all the feeds I need. Now, this is a 5-wire plug. In a 5-wire plug, we have power and earth for the motor, 5 volt reference, a signal wire to command the movement, and then a feedback wire which tells the ECU where it's at. The next stage is to put some breakout wires between the plug and the motor. I'll then be able to command movements and look at the line of data with a diagnostics machine. Some time ago, I managed to pick up a kit of cables. They are getting a little bit old now, so I am going to have to test them before I use them. This is them, and I need these ones. They have a female end and a male, and then they have this bit where you can plug in your voltmeter or link to other wires. They are old, so I'm just going to test them. That one's good. That one's good. Good. Last one. I'll be right back once I've connected everything up. That was a ridiculously fiddly job because the plug is facing the wrong way. However, I got there in the end. What I'm going to do now is I'm going to command movement using the diagnostics machine and see what's going on with the voltmeter as I do it. So here we go. Green. They're the two most important ones, but I may as well check the other ones while I'm here. Well, that wasn't really that helpful actually, it hasn't told me anything. But what I do know is the motor is not moving. I'm of the opinion that I haven't got a problem with the wiring, and with the fault code being what it is, that we've actually got stuck flaps. So it is just a case of whether or not the motor's burnt out as well. There's no way of accessing the flaps, so I'm just going to pull the cover off the motor and see whether I can manually move them. The flaps are in here, which is pretty impossible to get to. You've got to take off all of this. So no. I'm going to take off this cover and I'm going to see if I can access the gears and move it manually. Let's get some more tools. 25. They're just a Torx 20 and I've got my T-bar. Got bored of the T-bar. Here we have the motor. And at the bottom, just here, we've got half of the Hall sensor and the other half is just there. This part of it is moving freely. But if I wind it all the way around to the end, it doesn't spring back. It gets stuck just here. If I just give it a little tap, it will release. Just like that. And that is what has burnt out the motor. I better go and discuss with the owner their options. Yeah. No, as I said, I think that is the best option. Okay. All right, I will get that sorted for you. Speak to you soon. Bye. Having spoken to the customer, I've explained all their options and all the costs involved, and they've decided they just want to map it out. This car is at the end of its life. It's done 202,000 miles, and spending £1,500 replacing the entire inlet manifold is it's just not worth it. I'll just go get my equipment to map it. Gonna need a laptop. And what did you get? Magic box. OBD cable. I'm going to map the car today using my auto tuner tool. This is a master tool because I write my own files. Let's plug it in. Select ECU operations. Nice picture of a car. Scroll all the way down to Volkswagen. Scroll for a look for a Passat. Few choices. Ours is V6 from 2005. There's quite a few choices here of ECU. I'm going to go with, I'm going to select this one, but then I can just do an identify and it will correct it if I'm wrong. We're on OBD connection. Turn the ignition on. Identify. Okay, so it's telling me that I selected a CP20 and it's telling me that it's actually a CP14. Let's go back. Select the correct one. Back again. CP14, right next to it. OBD again. Identify again, best to make sure. Okay, now that's all right, so your ADCU. So this one's telling me it's a virtual read. The reason for this is that Volkswagen protect their ECUs from being read, but you can overwrite them easily. Just need to save and pause. Now I just need to upload it onto my server so I can map it. Normally when mapping a car I have to make a lot of manual changes, but in this case this is such a common thing for this type of car and this engine that there's actually a plug-in for turning the swirl flaps off. So all I need to do is click on it and the map is created automatically. Now all I need to do is write my new file to the ECU, and that just requires me clicking on the file and uploading it. So in a couple of minutes that'll all be done. One thing you do need to do when you're mapping a car is make sure that the battery voltage stays where it needs to be. I normally use a stabiliser, but because it was so noisy for the camera, I've linked this one to a lorry battery. One of the things I chose to do on this job was to lock the flaps in the middle position. Most people don't bother doing this, and it can cause issues with the car. If the flaps are fully open, the car gets maximum performance, but suffers with poor starting and low torque. If the flaps are fully closed, it suffers with hot start issues and doesn't have the top end performance. By setting them in the middle position, it's a balance between all of these factors. Car's up on the ramp, ready for me to look at the ABS, but I'm gonna go get some lunch and I'll see you on our next episode.